Hello, folks. In this video, I'm going to walk you through the process for doing a hypothesis test. We're not actually going to do any hypothesis tests in this video. I'm just going to walk you through the process, okay? And very similar to confidence intervals, I have an acronym for you to help you remember all of the steps and to get all of the points whenever you do a hypothesis test, okay? And that acronym for hypothesis tests is PHANTOMS, PHANTOMS. Okay, there's more steps in this than in a confidence interval, but a fair number of the steps are short and will likely look very familiar to you. Okay, so let's go ahead and jump in here and talk about these different steps. Okay, so the first step, P stands for parameter. Exactly the same as a confidence interval. Okay, so what you do here is you state the parameter the test will examine. Okay, that's it. H stands for hypotheses. Okay, or hypothesis, right? And what you do at this step is state your null and your alternative hypothesis. Okay. All right. A stands for assumptions, okay? i.e. checking conditions, right? So what we do at this step is we check the conditions necessary to perform the hypothesis test. Okay? And shocker, shocker, our same three conditions show up again. The randomness condition, the 10% condition, and the success-fail condition, right? Or again, that's sometimes called large counts. So just as a reminder for you, the randomness condition is you have to have a simple random sample, so an SRS, or a randomized experiment. The 10% condition is, is the sample size less than 10% of the total population? So sample size is less than 10% of the total population. So remember, the way that we typically check that is we do 10 times the sample size, and we check to see, is that less than the total in the population, right? And then the last one is success-fail, large counts, okay? Exact same formulas as before. We have to check to see if the number of successes and the number of failures are both greater than 10. So you're doing NP has to be greater than or equal to 10, and N times 1 minus P has to be greater than or equal to 10. Now, the difference between doing this condition, the success-fail condition, with hypothesis tests over confidence intervals is with hypothesis tests, you actually do have, technically, the true value, right? Because you have a claim as to what the true value is. So here, each of these, right, P in both of these instances is the parameter value, so the true proportion, right, which comes from your null hypothesis, so the claim in the null hypothesis. Right? N, just like with confidence intervals, stands for name the test. Okay, and then another thing that we do at this step is state the alpha value. Right? Which is your significance level. Okay, So when you are naming a test, there's a couple of questions that you have to ask yourself, and I have them listed on the left side of the screen here, but I'm also going to write them out here, okay, which is how many samples are we dealing with? So number of samples, okay, is this a Z test or a T test, okay? And really, I should just say Z or T. So is this Z or T? Is this a test or an interval? Okay, and are we dealing with means or proportions? Okay, in this unit, we're dealing with proportions, okay? Since we're doing a hypothesis test, the answer to this third question here is test. With proportions, the answer to the second question is almost always Z. So Z goes with proportions, right? And then number of samples will vary, right? Depending on the context of the problem. Okay? All right. So all of that, those first 4 steps is just to set like the stage for us doing the math. Okay? So the math comes in the middle with steps T, O, with steps T and O. Okay, and then after that, you have your conclusion. Okay, so T stands for test statistic. Okay, and what you do at this step is you calculate your Z value. Okay, and how you do that is here on the next page of your notes. Okay, so calculating a test statistic is just like calculating a Z-score, right? Because what you're trying to figure out is how far your sample statistic is from the parameter or from what we would expect if the null hypothesis is true. Okay, so the formula for your test statistic, right, is you take your statistic minus the parameter and divide that by the standard deviation of the statistic. Okay. Let's see if I can get this to cooperate with my, oh, then again, maybe not. There we go. 1 second, y'all, because I'm having to write this as a fraction, okay? But I really am, I'm hoping that this looks familiar to you, right? This is essentially a Z-score formula, right? This is essentially a Z-score formula, right? Your standard deviation, right, is down here at the bottom, right? Your parameter is usually the mean of the sampling distribution, right? And your statistic is like your data point. Okay, so exactly the same as when you calculate a Z-score. All right. Now in, oh, wrong thing. Okay, so with proportions, your statistic is your sample proportion. So P hat, your parameter is your true proportion, P, and your standard deviation is this formula that I'm hoping, now that you've seen it both in Unit 6 and with confidence intervals, that this is looking pretty familiar to you. So P times 1 minus P divided by N, all under the square root. Okay, very similar to the differences that you see up here with the assumptions where you're going to use your true proportion or the claim at what your true proportion is. You're going to do the exact same thing when you calculate your standard deviation of the statistic, right? The only reason in confidence intervals that we use P hat inside of this calculation for the standard deviation of the statistic, the only reason we use it is because we don't have the parameter. We don't have the true proportion. But in hypothesis tests, we do, right? We have to have a claim at what the true proportion is. So if I have that information, I should use it, right? Because that's the most accurate version of the standard deviation. Okay, so you're going to use that to calculate your test statistic, right? Which in this case is like Z. Okay, all right. So that's like most of the math. Okay, and then O stands for obtain p-value. So that's what you do when in a typical normal distribution problem or a sampling distribution problem where I have you draw the normal curve, sketch out the normal curve, right? Draw where your mean and standard deviation are, draw your data point, your statistic, right? And shade to the left or shade to the right, depending on the problem, right? Okay. And then use either your Z table or your calculator to find a probability. Okay, so what you do here at this step is you draw your normal curve, okay, shade the p-value region, find the probability that, I need to move this over a little bit, that p hat is, hold on, is less slash greater slash not equal. I know you all can't see this right now. 1 second. Is less, greater, not equal to the parameter with or using the normal distribution. So that's your Z table or norm CDF. Okay, right? And this should be p hat right here. Sorry, I don't have that symbol, so I have to draw it in. Okay, so essentially what you're doing here is you're figuring out your p-value is the probability that you get from the normal distribution, right? Because what you did up at the top here in this previous step, the test statistic, is you found a z-value, right? So I'm hoping that as you are kind of watching and seeing all of this, that it's like, oh, it's basically normal distribution, right? Like we're doing all of these steps that we've been doing for a while, like since back in September when we first talked about normal distribution. Sampling distribution was the same type of thing, right? And now this for hypothesis tests, similar idea, okay? So what you're finding is your p-value, which is either the probability that p hat is less than the claimed value, right? Or that p hat is greater than the claimed value, depending on your hypothesis, right? Depending on your alternative hypothesis, right? So like this one here would be for if your HA was that P was less than something. This one would be if your HA was that your true proportion was greater than something, okay? And what that translates to is the probability that any Z value would get is less or greater than your test statistic value that you calculated in the previous step, okay? These right here are for one-tailed tests. If you have a two-tailed test where your hypothesis, your alternative hypothesis is a not equal to, right? What you do with that is you multiply your p-value by 2, right? Which you can kind of see in this image right here. Okay, so when your alternative hypothesis indicates that we just are looking at a change, we don't know if it's less or greater than the stated value, we just think it's different, right? Then that means it could be the p-value is all the area to the left of a particular a particular z value, right? Of your test statistic, right? Because that would encompass the less than possibility, and also the area to the right of a particular z value, right? But one is negative and one is positive, right? So it's like the tail, it's both tails essentially of the normal distribution, right? The lower tail is your less than possibility, and your upper tail is your greater than possibility, right? Because I don't know if it's less or greater, I just know it's different, okay? But because a normal distribution is symmetric, you don't have to calculate both. If you can figure out one of them, the other one has to be the same because a normal distribution is symmetric. So what we do, right, in order to save time, right, rather than having to calculate two test statistics and do all of that crazy stuff, is just whatever value you get for your p-value, multiply it by 2 so that you're encompassing both tails. Okay? All right? That's the math. Okay? And then the last 2 steps here are your conclusion steps. Okay? So M stands for make a decision. Okay? So what to do at this step is decide if you're going to reject the null or fail to reject the null based on your p-value and your significance level. Okay, so remember, your significance level is like your standards, right? So if the p-value is less than your alpha value, right, less than your cutoff, you're going to reject the null. So you're going to reject H sub O. Okay. If the p-value is greater than alpha, you are going to fail to reject the null. Okay. And then my very last step is to state the conclusion in context. Okay. Just like the interpretation of a confidence interval, right? You have a word formula here. Okay. So here's how you should interpret, state your conclusion. This is how you should phrase this. Okay. So you would say, because the p-value is really, you should say, because the p-value which equals insert p-value is, and then you would say less or greater than alpha, we, and then state your decision, reject or fail to reject the null. We, and then you say either do or don't. So if you're rejecting, you do have enough evidence. If you're failing to reject, you don't. So we do or don't, depending on your decision, have enough evidence to support H sub A, so your alternative hypothesis, which states that the true, and then you would essentially state parameter with alternative hypothesis in context. Okay, so what you end up filling in is your p-value here, whether it's less or greater than alpha, your decision, so reject or fail to reject, and then what that means. So either you do or don't have enough evidence to support your null, which states, and then provide the context. Okay. One quick note here is that this part you can write this as p-value which equals blah, 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 blah. And you can write this as like greater than alpha or less than alpha. You don't have to write the word alpha out, right? Okay, y'all. So that is your process. Okay. In the next video, I'm going to go through a couple examples for one-tailed tests, and then I have one more video for you after that with an example for two-tailed tests. So you're going to see 4 full hypothesis tests worked out between those 2 videos, okay? And you'll be able to see the very small differences between the one and the two-tailed tests, all right? So with that, I will see you all in the next video for the examples. Bye, everybody.